In this problem, we are going to look at a calculus question. The question states that there is a function f that is defined from minus pi by 2 to pi by 2, that is the domain, to R, which is the set of real numbers. And the function f is a continuous function such that f of 0 is 1, and also integral of f of t from 0 to pi by 3 is equal to 0, right? And then we have to select which of the options are correct. And this can be a multiple correct question where more than one option could be correct. So the first option says that decide whether equation f of x minus 3 cos 3x equal to 0 has at least one solution in 0 to pi by 3. And the second option is a similar option. It says that find out whether the equation f of x minus 3 sine 3x is equal to minus 6 by pi has at least one solution in 0 to pi by 3. And the last two options are two limit calculations which involve the integral, right? So let's look at this problem and try to understand how we are going to solve this. This is an interesting problem, especially because we have an integral condition and we want to make use of or try to understand how we will utilize this condition, right? So if I have to find out whether a particular function is having a solution in a particular range, then usually what we need to figure out, like for example, if I give you a function g of x, if g of x has some root in a range a to b, right, then what we need to show is that, first of all, if g of x is continuous and it changes sign, if it changes sign in this interval, what I mean by that is g of something c should be greater than 0 and g of d should be less than 0, right? And c and d lie inside this interval. Then that will prove for us that since the function was continuous and one place it was positive and one place it was negative, then the function must have changed its sign, so must have become 0 somewhere between c and d, right? And if we are able to show that it becomes 0 somewhere in C and D, then it has at least one root in C and D, right? Or that is inside the interval A and B. So it's that principle that we are going to apply here. So let's think about that for a bit, right? So here, the equations that we have to solve for are f of x minus 3 cos 3x, right? Equal to 0. And similarly, f of x minus this. So I can say that I will define a new function. Let's say my new function is g of x, which is equal to f of x minus 3 cos 3 of x, right? Correct. So this function is there, and I have to find whether g of x is equal to 0 in 0 to pi by 3 or not, right? Whether g of x will be equal to 0 in this interval or not, right? Now I'll utilize this condition. I know that the integral of 0 to pi by 3 of ft dt is 0, right? So why don't we find out the integral of 0 to pi by 3 of g of x, right? I will do that on the next screen. So let's see. Integral of 0 to pi by 3 of g of x, let's find out, right? So that is equal to 0 to pi by 3 f of x minus 3 cos 3x dx, right? Okay, so this integral can be split like this: 0 to pi by 3 f of x minus 0 to pi by 3 3 cos 3x dx, right? Okay, now the question itself has told us that this integral value is 0, right? So that is 0. Let's evaluate this one. So this becomes minus 3 sine 3x by 3 evaluated from 0 to pi by 3. And you will realize that this integral is also coming out to be 0. Sine 3 into pi by 3, sine pi is 0 and sine 0 is 0. So basically we come to know that 0 to pi by 3 g of x dx is equal to 0. Now what does this mean? Think about it. This means that the area of the function from 0 to pi by 3 for g of x was somehow equal to 0, right? And if you know, area will be equal to 0 only if the top part area, the positive area, is being cancelled by the negative area, right? Area cannot be 0 if the function was above the x-axis all the time, right? Then it would be only positive area. So that means g of x is such a function that it must have a portion in the top of the x-axis, above x-axis, where it is positive, and also some portion below x-axis, then only the total area from 0 to pi by 3 was equal to 0. But that means what? That means the function must cross the x-axis somewhere between 0 to pi by 3, right? It must cross the x-axis some point, right? Then only it will go to the negative side. So basically, this condition implies that g of x equal to 0 has at least one root, right? It may cross the x-axis multiple times. The function could be like this, right? 0 to pi by 3. And somehow the negative areas are cancelling the positive area. It could have more than one root, but at least it has one root, because otherwise it can never have zero area, right? So that is the idea by which you're using the integral information, right? Similarly, we can do the next part of the question, 0 to pi by 3. This time I'll take my function for the second option, basically as f of x plus 3 sine 3x and plus 6 by pi. This is my new function, and we'll check the value of this integral. And we will see that this integral is 0. This will be minus 3 cos 3x by 3 evaluated from 0 to pi by 3. And the last one will be 6 by pi into x evaluated from 0 to pi by 3. This becomes minus cos pi, minus plus cos 0. So that is basically 2 plus this becomes 6 by pi into pi by 3. This is actually minus 3 cos pi, so plus 1. Right. Minus cos pi is plus 1 minus plus. This is 2. And this becomes 6 by pi into pi by 3. This is also 2, right? So technically what I'm getting is, okay, I have made a mistake. This here the area is coming out to be 4, right? But I have made a mistake in choosing my function. My function should have been f of x minus 3 sine 3x and plus 6 by pi, according to the option. So you go back to the question, this should be my function, right? Because the equation given in the question was f of x minus 3 sine 3x is equal to minus 6 by pi. Here I have taken a plus sign here. That's why I'm getting in here minus, instead of minus 2, I'm getting plus 2. But if I take a minus sign here, right, then what I get here is minus 2, and this minus 2 cancels with the 2 and becomes a 0, right? So in the B option also, I'm getting that this g of x, integral of 0 to pi by 3 of g of x is equal to 0. So g of x definitely has some root in this interval, right? G of x has some root in the interval because the area cannot be 0 unless g of x crosses the boundary, crosses the x-axis. It should be positive someplace and negative in the other place, right? So basically we are getting option A and B are correct. And now let's look at the limit options. So limit x tends to 0. We have x integral 0 to x f of t dt by 1 minus e power x square. And we can see that this is fitting L'Hopital's rule condition because this is 0 by 0, right? Because e power 0 is 1, so 1 minus 1 is 0. So let's apply L'Hopital's. On top, you will get 1 integral 0 to x f of t dt plus x into derivative of this is f of x. Yes, f of x divided by minus e power x square into 2x, right? Okay, we are getting this. Correct. This is still 0 by 0. So maybe we have to apply L'Hopital once more here. So let's do once more. Let's try it out. It will become f of x when you differentiate this plus f of x plus x times f dash x, right? Divided by, you will get minus 2 into e power x square plus 2x into e power minus x square into minus 2x, right? This is what we are getting. Now, this is not tending to 0. The denominator here is tending to, when x is 0, it's tending to minus 2, right? And the numerator here is tending to, when x is 0, it's tending to twice of f of 0. F of 0 was given as 1 in the question, so it is tending to 2 plus 0. And here it was minus 2 plus 0, so the answer is minus 1. So we are getting option C by a direct application of L'Hopital's rule. You just have to do it 2 times, and you have to use Newton-Leibniz formula for differentiating an integral. We have covered that in a previous video, so that should not be a problem, right? Option D also, if I try limit x tends to 0 sine x by x square, an integral of 0 to x f of t dt, we can probably separate it like this: sine x by x and integral 0 to x f of t dt by x. And we can do limit for this and limit for this as x tends to 0. This limit will tend to 1, and this limit will be f of x by 1, which is also 1 because f of 0 is 1. Here I am applying L'Hopital. So this whole limit will come out to be 1 into 1, which is 1, but the option is saying minus 1. So that is incorrect. So in this case, the answers are A, B, and C. The key point that I want you to take away from this question is the fact that if integral of a function is 0 over some interval, then that function must have a root between that interval, right? Because the function has to change sign from positive to negative, so it must have crossed the x-axis at least once, right? So you should know that, and you should utilize that in future problems. That's it for this video. If you like the channel, if you should subscribe to it, you will be getting notified about future videos. You can press the bell icon, subscribe to the channel, and I'll be bringing more content for you for Olympiads and JEE Advanced. See you in the next video.